This is section R-2 titled Integer Exponents in Scientific Notation. So we're going to look at the laws of exponents, and letter A gives us those laws. So make sure you take a chance to review them and look them over. And as we do the examples, I'll be referring back to those laws for the steps that we take to when we look at the examples. Okay, so make sure you read the rules first. Or if you're already familiar with it, then that's already fine. Let's do a couple of these problems. We'll do two. I'll do two here, and then we'll do two in class. So number one, negative 2 to the 2x times negative 2 to the 3y. So whenever we have, this is rule, by the way, rule number 3, the product rule, which says a to the mth times a to the nth is a to the m plus n. That means when you have the same base multiplied with whatever exponents they have, you can just add the exponents. And so in this example, negative 2 to the 2x times negative 2 to the 3y, the base is negative 2, so we're going to repeat that base. So the answer will be negative 2 to the, and then we're just going to add the two exponents, 2x plus 3y. And we can't simplify that, so that's our answer as far as simplified as it can be. All right, let's try number 3. And number 3, you know what, let's try number 2. Number 2, 3z squared. That means that the quantity 3z squared is squared, and then times 4z to the negative 4th power, where that negative 4th power is only on the z. Okay, so first we need to square the first quantity, the 3z squared. It's supposed to be squared, so we're going to square it, and we squared each of the factors. So we're going to square 3. 3 squared is 9. We're going to square z squared. That'll be z to the 4th. And now we're going to multiply times 4z to the negative 4th power. Notice that the negative 4th again is only on the z. All right, so I'm going to, this is all multiplication, so I'm going to choose to multiply 9 times 4, which is 36. And then z to the 4th times z to the negative 4th is z to the 0 power, or 4 plus negative 4 is 0, I'm sorry. And so it's 36z to the 0, but z to the 0, rule number 1 tells us is 1, as long as z is not 0. So we're going to say this is 36 times 1, that's our z to the 0 is 1, and then that'll be 36. All right, and we'll leave examples 3 and 4 to be done in class. Just a hint on number 4, you cannot really, you're better off not having negative exponents. And so you want to get rid of those, and I would say work on getting rid of the negative exponent on the inside first and simplifying the inside of the exponents on number 4, and then applying that negative 2 power, but making it a positive exponent first using the rules that are listed at the top of the page. Okay, and we'll leave that for class. Let us go on to R3, rational exponents and radicals. Okay, so properties of rational exponents. Let m and n be a positive integers with m over n in lowest terms, the fraction m over n in lowest terms, and n greater than or equal to 2. Let r and p be rational numbers. Rational just means fractions, by the way. If b is a non-zero real number, and each expression is a real number, then the rules that are listed there apply. Let's read through them. So b to the 1 over nth power is the same thing as the nth root of b. And b to the m over n is b to the mth quantity to the 1 over nth power. Or it can be written b to the 1 over nth quantity to the mth power. And letter C, b to the m over n, can also be written as the nth root of b to the mth power, or the nth root of b quantity to the mth power. Okay, and so all this tells us is that whenever we have rational exponents or exponents in the form of a fraction, the top number is the root, the power, and the bottom number, the denominator is the root. So the numerator is the power, denominator is the root, whenever we have a number to some fraction power. All right, let's look at some examples. So example A says simplify. Number 1, 32 to the negative 3/5. So 32 to the negative 3/5 first of all, I want to make that a positive exponent, so it'll be 1, I'm sorry, it's negative 32 to the negative 3/5. So it's 1 over negative 32 to the positive 3/5. Okay? Now I'm going to apply what we just learned right now, that the power 3/5, the numerator is the power, denominator is the root. So I'm going to take 1 over, and you can do the power or the root first. Both of those should be possible, and if they're not, that means you can't work that out. All right, so I'm going to take the 5th root first. So the 5th root of negative 32, and then I'm going to take that to the 3rd power. So this is 1 over. The 5th root of negative 32 is negative 2. And now we have to do that to the 3rd power, so that'll be 1 over negative 8, or negative 1 over 8, or negative 1/8. All right. Number 2, we're going to leave to discuss in class. You can try it before we get there, but we'll discuss it in class. Let's go on to example B. Write as a single radical the square root of the cube root of y. Okay. And this one, we'll start it off, and then, we'll finish it. So, the way I would do it is, remember, we can switch between writing radicals or roots and rational powers or exponents. So the square root of the cube root of y is the cube root of y to the 1/2 power. That's the square root of the cube root of y. I'm going to do the same thing with the cube root of y. The cube root of y is y to the 1/3 and then to the 1/2. And then remember, the rule from before says we can multiply those two exponents. So this will be y to the 1/6 power. And the instructions say write as a single radical. That means we have to use the root symbol. So y to the 1/6 is the 6th root of y to the 1st power. So it's just the 6th root of y. That's our answer. All right, let's go on to part 3. Properties of radicals. Let n be greater than 1 be an integer and a and b be real numbers. If each expression is a real number, then we have some rules that apply. If n is even, then the nth root of a to the nth is the absolute value of a. If b is odd, then if n is odd, then the nth root of a to the nth is just a. The nth root of a times the nth root of b is the nth root of a times b. Notice that that's assuming that each of those can be worked out. And then the nth root of a over the nth root of b is the nth root of a over b. And finally, the mth root of the nth root of a is the mnth root of a, which we actually just discovered on the example we just did. All right, let's do a couple of these, and we'll leave the other one for class. Okay, so let's try number A, the 4th root of 3x minus 1 to the 4th. So the rule that applies here is the rule number A that we just read, that if n is even, then the nth root of a to the nth is the absolute value of a. So the answer here will be the absolute value of 3x minus 1. Okay? All right. And then let's try C. So we'll skip B, we'll go on to C. So we want to simplify the cube root of 16x to the 4th minus 7x times the cube root of negative 2x plus the cube root of 54x. All right, so the first thing you'll notice is that the smallest radicand is the minus 2x. And what we want to do is try to make it look like try to make all the radicands look the same. So can we do that? Well, if we look at the cube root of 16x to the 4th, that's like taking the cube root of 8 times the cube root of 2, that's the cube root of 16, times the cube root of x to the 3rd times the cube root of x. Yeah, that would be the cube root of x to the 4th. And so what you'll notice is we can simplify the cube root of 8, that's just 2, the cube root of x to the 3rd, that's x, but we cannot simplify the cube root of 2 and the cube root of x, so that means the cube root of 2x will remain, and that tells us that that second term, the minus 7x times the cube root of negative 2x, we want to write it in terms of the cube root of 2x. So this is minus 7x, that needs nothing done, times the cube root of negative 1, notice I'm factoring the negative 2x into negative 1, times the cube root of 2x. Okay? And we're going to do the same thing to the last one, plus the cube root of, and 54x is 27 times 2x. So it's the cube root of 27 times the cube root of 2x. Notice that we can find the cube root of 27, and that's why we want to do it that way. Let's simplify. So we have 2 times x times the cube root of 2x, that's from the first term, minus the cube root of negative 1 is just negative 1 times negative 7x is plus 7x times the cube root of 2x, plus the cube root of 27 is 3 times the cube root of 2x. Sorry about that, I'm missing writing my cube roots. Alright, and so we have 2x cube root of 2x plus 7x cube root of 2x plus 3 cube root of 2x. And so we can combine the 2x and the 7x. Those are like terms with like radicals. That's 9x cube root of 2x plus 3 times the cube root of 2x. Okay, we can leave it that way. Some people like to factor out 3 cube root of 2x. You don't have to, because you can't really do anything with that. You just write it in factored form. So we'll leave it like that. All right, so don't forget to go back and look through the examples that we didn't do, and we will discuss them in class, so we'll have time to look them over at that time. Okay, that was sections 2 and 3 of chapter R.